Hi guys, and thanks for stopping down at Pete's Garage. Ever since I made the how the cylinder head works video, I've been getting requests about blocks, and people would like some information about blocks and what they need to do to get their block performing the way they want it to, and what they can have done to their block to get optimum performance out of it. I have a block here. We'll talk about the different kinds of blocks first. I have some models here of blocks, some rapid prototype castings here that'll be able to talk about the lubrication system and how oil gets around the blocks. I have a 6-cylinder and 8-cylinder, and I'll go through the bearings, the different kind of bearings that go into blocks, what they mean, what different kind of bearings you can get, and we'll talk about the different machining things that you can do to your block to increase performance and what that really means to the overall performance and how it affects the other parts of the block. So let's get started. Let's start with the bottom of the engine and talk about the bottom part of the block, because there's a difference between a block and a crankcase. Believe it or not, there is a difference. Now, first, if you look at this block, you see how this main bearing is outside of the pan rail here for the oil pan. It sits outside. Half of the crankshaft, if you put the crankshaft in here, only half of it would be sitting inside the block. So this is a block, a cylinder block. In comparison, let me show you real quick a picture of a crankcase and what the difference is. For a crankcase, you can see how the main bearing cap and the bolt completely sit below the pan rail for the crankcase. This is a crankcase. It's a crankcase when the bearing and the crank sit inside, completely inside the pan rail. Block is outside, crankcase is on the inside. So now that we have gone through what the difference between a block and a crankcase is, let's talk about the bearings and what different kind of bearings are and the most important part of bearings. First of all, there's really a couple kinds of bearings. This bearing here looks like it's used, but it's actually brand new. It's a dirty bearing. It's not a coated bearing. This is used in a lot of racing applications, and it's not coated, but it is a very high quality bearing. In contrast, if you look at this bearing, you have your typical bronze bearing that's coated with a material to make it last longer. This is something you would find in a brand new engine, a car that you would buy. A brand new engine would have this kind of bearing in it, shiny surface. But there's different kinds of bearings you can get depending on your application and how much you're going to push the engine. You can choose different bearings for different kinds of performance. But the most important bearing we're going to talk about is this bearing right here. This bearing is the thrust bearing. And this bearing sits in the middle of the engine, and on this block you got the front of the engine here, so it's 1, 2, 3 bearings back is a thrust bearing, and you can see the thrust bearing in here. You got this thrust plate in here. Now let me set the crank in here and let me show you how this matches up. I'm going to take this off, I'm going to put the crank in here, and I'll show you what that thrust bearing does. So now I have the crankshaft sitting in the block, not the case, the block. I'm going to pull off this bearing cap and show you that this is where the thrust bearing resides. Okay. Now what this thrust bearing does is, I'll take a close-up of this. You can see down in there where the thrust bearing sits. And the thrust bearing rides against these thrust surfaces on the crankshaft. They're machined very, very close tolerances. So when you check the end play of your crank, you are really checking how much this moves back and forth. And you have to have a certain amount of play in between this thrust bearing, because what actually happens here is when you step on the gas, according to the laws of physics, when you have centrifugal motion, the resulting force is always 90 degrees. So when you step on the gas, you have the piston pushing this direction, right, out, in and out. So the crankshaft wants to move this way. So when you step on the gas, the crank moves one way. When you let go of the gas, the crank moves the other way. And this thrust bearing absorbs the energy, or that friction, of the crank moving forward and backward. So the clearance for the thrust bearing, and checking the end play of your thrust bearing clearance, is very important when you do that. Okay, so you have your thrust bearing right there, and that's how the crank sits. Again, going back, you can see how the crank sits halfway inside of this block. So that's the main purpose of the thrust bearing. Now I'm going to talk about the rear bearing here for a minute. This is the rear bearing cap right here, and the rear bearing cap goes on the back of the crank just like that, and this is where your rear seal would go. Now when you put your rear bearing cap on, what you want to do is, to make sure that it doesn't leak at the rear bearing cap is before you put the bearing on, you want to put an anaerobic sealant in here. And there's sealant just for this, you can buy it. But you want to put some sealer on this surface so oil doesn't leak through this bearing and come leaking out the back. Then you will have what you think is a rear main leak seal leak, but it's not. It's actually leaking through the bearing. So put some sealant on there. You can put some on the front as well. So on the front surface, put a little anaerobic sealant on there, much like a high-tech, real thin sealant, so that when you put the cap on and put it in place, nothing is going to leak through the bearing cap and come through out and leak in your engine, leak outside and drip on the floor. Now before I turn this block over and rotate and we talk about other parts of it, I'm going to talk a little bit about lubrication. Oil, when you look at the bottom of the crank and through the bearing, this is where the oil is forced through. High pressure comes through here, forces through the bearing into the crankshaft. And when it goes in through the crankshaft, it goes through different holes drilled in the crankshaft and how it gets to connecting around. That's how the oil gets through the block. And I'll show you that on the model. But something I want to show you that are becoming more and more popular on engines, which is an old diesel technology, but this is called a squirter, an oil squirter. And what new engines are having, you have the smaller four-cylinder engines that are higher revving and using higher heat, and they're trying to squeeze as much horsepower out of the four-cylinder engine. And what they do is they put this in, it's an oil squirter. And what this basically is, you can see there's a ball in there, and that's a check valve. And this gets mounted, in this case it would be mounted somewhere down in here. And what this actually does is it squirts oil directly on the bottom of the piston. If there were a piston there, you can see how this would squirt oil right on the bottom of the piston. The purpose of that is to saturate or completely soak, or whatever you want to call, put as much oil on the bottom of the piston as possible to take the heat away from the piston head. Squirters like this are put in there to reduce heat, take heat away from that piston. Pistons are getting smaller, reducing weight, bores are getting smaller, and a squirter like this is used to soak the bottom of the piston and take the heat away as fast as possible. So if you work on an engine small four-cylinder, you're going to see a squirter like this becoming more and more common on engines today. Now, before I turn this over, let's talk about the side of the block. You'll usually have a couple mounting holes. Depending on your engine, you might have bolts that go straight through the main bearing here. You'll have a hole where the hole is for the dipstick. Okay, then you'll have your mounting holes for the thing, for the mounting where it mounts in your car. You'll have your mount for your oil filter right here, and that's pretty common on all engines. One thing I'd like to talk about or share with you, most people call these freeze plugs. And they say these freeze plugs are here in case the engine gets cold, and these plugs pop out so that the engine doesn't crack. Well, that may be true. But what these actually are is when this engine is poured and the cast iron is poured, these holes in the mold are actually where the cast iron is poured into the mold. And this is left over, and what they do is they cut these off, machine the hole, and put a plug in there. So yeah, these are freeze plugs as people call them, but they're actually core plugs. That's how the cast iron gets poured on. There's 3 on each side, and that's how the cast iron gets into the mold when they pour the block itself. Now I have this on a stand. I'll try and turn this with one hand. See how successful I am. And as I turn it, not as easy as it looks. Okay, now we can talk about the side and the bore. When you get a block, you're always going to have it cleaned up. You want to have it cleaned up as much as possible. You want the surfaces to be clean. Let me try and turn a little bit more. There we go. A little bit more. Okay. You want to have these surfaces cleaned up as much as possible. So you take it to a machine shop, and the important features are on your bore, you want it to be round. The first thing the machine shop should do is put a bore gauge in there and check to make sure it's round. All the cylinders have to be round. If they're not round, it needs to be machined. Cutting it out right here. Now, when people say I have my block and it's cut 30 over, 40 over, what they mean is that 30 thousandths of this bore has been machined out all the way down to make the bore bigger. If you take this bore and make it bigger, you're increasing the size of the bore and adding cubic inches to the engine. But you have to be careful, because the more you machine this out, you can see the line where the gasket would go. If I keep on machining this out, I could machine past the gasket. I can get close to this coolant jacket right here. And if I do that, you run a risk of this cracking. So the thinner this gets, the smaller the gasket has to seal, and you can blow head gaskets really easy. So depending on the block you have and how it's cast determines how aggressive you can be when you have it bored out. That's the most important thing to think about boring. Now, the next thing you want to do is have the head decked. And what that means is the machine is put in a mill, and the mill is run across the face of the block just like this. And the purpose of that is to get this the surface perfectly flat so the cylinder head sits flat. You have your dowel pin here. This dowel pin is just an alignment pin for the cylinder head. When you put the head on, that lines up the head. But you want to have this decked. It's got to be flat. Now, as you deck this surface, as you can imagine, if I were to take this surface and machine it down lower, 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 the more I cut off the head deck, the smaller the combustion chamber is going to be, or the closer the piston will be to the cylinder head. So you run the risk of hitting the piston on the valves if you machine enough of this off and the head gets really close to the piston. So you can only cut off so much of the deck surface here before you run into problems with the pistons. And another thing to remember is, as you cut this down, you're making the combustion chamber smaller because you're taking the cylinder head and you're lowering it down, and you're reducing the space inside the cylinder. As you do that, compression increases in the engine. So if you have a cylinder head, let's say you measure the compression and it's 9.5 to 1. Then you want to have this deck down, and they cut this off maybe 4 thousandths. Your 9.5 to 1 push that cylinder head down, and your 9.5 to 1 now just went to 9.7 to 1. So you increase the compression by cutting off the surface of the deck surface, which is okay, but you got to make sure you match the compression with the piston and the height and the deck surface so that you're using the right octane gas. You're not going to get pinging. There's all kinds of things involved there. So let's look around the rest of the block here. This front and back edge is referred to as the China wall, and that's just the front and back where the intake manifold sits. We have the holes here. This is where the lifters go in, oil return holes for the oil return, and there's plugs up here. You got some oil return holes back here. And then looking down the front of the block, this happens to be a Ford, so we have the distributor mount up front. The cam is still in here. I haven't had this off. This is my Cobra engine. I'm getting ready to put it back together. We have the coolant. This is where the coolant flows through in and out of the block to keep it cool. So what I want to do real quick is show you. You can look in here and you can see there's a plug. That plug right there, there's 3 of these plugs always drilled in blocks, and they're drilled with a gun drill straight through the block. And let me go to the model right now because I want to show you what that hole is, why that plug is there, and how the oil gets from the bottom on the oil pan. It gets pumped through the oil filter, and then it goes through high pressure lines through here and into the rest of the engine, starting with the bearings. So as I go to these models here, I have 2 different kinds of models. The first one here is a 6-cylinder engine. Now the interesting thing to note here, and this is a block because the crankshaft would sit halfway inside the block. The interesting thing to note here is that you see that there's not a valley here for the lifters. The lifters would actually sit in here, and this would be an overhead cam engine. So you'd only have the plenum mounted on top. You'd have the cylinder head sitting on each side. It would form a shallow valley, and you'd have a different arrangement there. So you can see how small it is. You can see how close the cylinders are together. So you can also look at the angle. There's different 90 degree, 60 degree, and 90 degree blocks. So if you were to see, if I were to hold these cylinders exactly like this, right here, if I was to get these perpendicular right here, you can see how this block is coming up at an angle. So this angle here, this is a 60 degree block. Okay? Now, if I take my 8-cylinder model, this is my 8-cylinder model right here, and this is actually a rapid prototype made from a drawing. So you actually have a model, a computer model of a block, and what happens is the computer will take a bed of resin and it will fire a laser beam at the resin and harden the resin, and as it traces around the block, this block would rise out of the resin, or the part rises out of the resin, and creates this thing. It's called a rapid prototype. So you can design something and have a model of it just as fast as you can draw it. Take a couple hours to make it, but it's kind of neat. But you can see 8-cylinder. 8-cylinder, we have the lifter valley here, the china wall on each end, the lifter right here, or the lifter holes on each side. Pretty much the same. Flat face, machined the same way. Core plugs, different mounts. Oil filter mount right on the bottom here. Now, the one thing I wanted to show you, we were talking about lubrication. And this is going to be a little difficult to see, but I'll do the best I can to show you. When oil enters the engine, and these are the 3 holes I was talking about. You can, let me turn the right side up. Here are the 3 holes. 1, 2, 3 holes. These holes are drilled, and if you can see here, they're drilled straight through the entire block. All the way through, from front to back. So you would have 3 holes in front of the block. And you turn around, you have 3 holes in the back of the block. Those are drilled all the way through, and that is how the oil gets around the engine, okay? That's how the oil gets around the block. The oil comes through the pump mounted inside. It pumps through the filter and immediately goes, which is hard to see. I will try and get this. You can see this. You actually see it from the front. Yeah. So you can see this from the front here, where the filter goes right here, and there's a kind of a runway here where this runs through here, and that sprue goes up to the top of the bearing. Now, you can look inside here. You can see this oil passageway, and I'm going to take a wire and stick it in here. See, and you can see. You see how that wire goes in there? That wire goes all the way up to one of those holes right here. It goes up to this hole right here. This high pressure hole, and that bearing right there is how the oil comes down from the high pressure oil line. It comes down and it comes out this way, and I think you can see that. See that wire in that hole right there. The oil comes down that way, comes down here through the center of the bearing, and that's what lubricates the crankshaft all the way up and down. Each one of these bearing surfaces right here has one of these oil holes all the way to the back. So the first thing that gets oiled is the crank, high pressure oil to the crank. Then it goes up, that oil goes there. Then it goes up to the lifters, depending how your engine is built or how it's designed. Then high pressure oil goes in through the lifters, and then it pumps up on top of the engine and on top of the valves, and then it drains back through the oil pan. So that's a basic look at a model, but the most important thing I want to show you there is how the oil gets through the block and then through these holes in the block, just like that, and how it gets from the top of the engine, where it's high pressure, the high pressure jacket that's all the way through the block, and how it gets down to the bearings first. That hole is drilled right there in every one of them. Going back to my full size block here, if I were to look at these cylinder bores, one cylinder bore going this way, one cylinder bore going that way, and if I would trace these lines straight through like that, it would make a 90-degree angle. So this kind of block is a 90-degree block. So you have 90-degree and 60-degree blocks. If you hear someone saying I have a 60 or 90-degree block, that's what that means. So we have the basic parts of the block. I talked about the bearings, the surfaces, the decking, what you can do to the surfaces, honing, make sure that your cylinders are honed when you put new rings in so they're seated properly. Make sure everything is very clean. This engine is dirty right now and I have to clean it up. But one thing interesting you can see, and I'm going to try and see if you can look inside there, which might be tough, but you can see, hold on a second, I'm going to grab a light and I will shine inside here, and if you look inside that lifter hole, you can see that line, that hole. That's the lubrication hole that's drilled straight through the engine, again, right here in front. I put the light up here. If you look at this right here, this hole is drilled straight through, and that is where those holes inside the lifter pocket, that lifter bore, that's how the oil gets through. So the oil pumps straight through all the lifters, equal pressure, pressurizing the lifters, and the lifters if they're hydraulic or whatever, hydraulic and solid lifters work the same way. So the oil gets pumped through, then it gets pumped through the lifter up on top of the engine and returned. So that's about the main points you want to look at blocks. Your deck surface, having it decked. Make sure your cylinders are round. They got to be cut round, milled, then honed. You can have that cleaned up. You can also have your surface here cleaned up where your manifold, intake manifold is going to sit. I got to scrape all the gaskets off to clean all that up and make sure when you put it together it's nice and clean. The last thing I'll talk about is the back. These are the transmission dowels. These are what made up with the transmission when you mount it to the transmission. So you got all your bolt holes that bolt to the transmission, but these are just dowels to help with alignment in the factory when I put it together. So those are the main points about blocks and crankcases. If you have any questions, please feel free to give me a call. And as usual, thank you for watching. Thanks for stopping by Pete's Garage.